Alright, so we are on page 5 of the packet, and we are on example 1. We are going to first graph these points. So it's -2, 3, 4, 3. This is L and M. 2, -2, and -3, -2. -4, -2. There we go. That's better. L, M, N, O. We're going to connect those. Just make sure you graph these points in the correct spots. And then what we're going to do is, it says it wants us to prove that it's a parallelogram. So we're going to find all 4 slopes and all 4 distances. So slope for LM, LM. Slope for MN, for NO, and OL. We're going to do the same thing for the distances. The distance between that one, MN, NO, and OL. Alright. So let's do the slopes first. One thing that you have to be able to identify is that when there is a horizontal slope, and what I mean by that, it's a straight line, it's not going up or down, you have to know that that is 0. So that slope is 0, that slope is 0. Because if you are counting from here to here, the rise over the run is just nothing. It is 0. So then we must count the slopes for MN and OL. So if I start at N and I count up, remember it's rise over run. So up 1, 2, 3, 4, 5. So make sure you count the spaces in between the lines, and then over 2. So 5 halves going to the slope. And then it's positive because if you put somebody on this line and they're walking to the right, they're walking up. If they walk to the right and they would be going down, then it would be negative. So this is going to be, I'll put equal signs here so it's not confusing. There we go. MN equals 5 halves, positive 5 halves. Alright, same thing for OL. You go up 5 over 2. Look at that, you're going to have the same slope. Great. For distances, if it is a straight line, so like for this diagonal line, you can't do this, but this is a straight line. All you have to do is count the spaces. So 1, 2, 3, 4, 5, 6 spaces in between L and M. And then if we count ON, 6 spaces. Or NO, something. 6 spaces in between. There are 2 ways that you can solve for the distance. I'm going to start off with this way, which is distance formula. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So write that down on your paper right now if you have not already. And we've got distance formula, so we're going to take our 2 points. We are trying to find the distance right here between M and N. So our points for M are 4, 3. Points for N are 2, -2. It's going to be our x1, y1, x2, y2. This should be a review for you. You have seen this before. Alright, so we need to plug our x and y values in. Big square root. Our x2 is 2. Our x1 is 4. So 2 minus 4 squared. Our y2 is -2. Oops. That should not be. There we go. Minus our y1, which is 3. So we are just plugging these numbers in there. Oh, yeah, I can't see that. That's off the screen. There we go. So that's our M and our N, because that's the distance we're looking for right now. Alrighty. So at this point, You got a couple choices. You can put all of this in the calculator, but you got to make sure you put it in correctly. Or you can, so it's 2 minus 4. So we're going to add a negative 4, and it's going to become negative 2 squared plus, add a negative 5 squared. All right, and then when we square a negative number, it's going to become positive. So we've got 4 plus 25. So this is our answer. Okay? So for mn, it's the square root of 29. We're just going to leave it under that square root. You don't have to turn it into decimals. We'll talk about that later, why it doesn't matter if it's in decimal or not. Now I'm going to show you the other way. So your other choice, so for finding the distance of LO or OL, they're the same, they're interchangeable, is by using Pythagorean theorem. A squared plus b squared equals c squared. Something else you can do. But what I'm going to do is I'm going to start at O and I'm going to put a dotted line all the way up to L. Notice what I'm doing. I'm making a right triangle. So now you've got a right triangle. You're going to use Pythagorean theorem. Now you can count the A and the B. So if we count up, it goes up 5 and over 2 for our right triangle. And now we're looking for the hypotenuse. Okay, so up 5 and over 2. 2 squared plus 5 squared equals c squared. Remember, this is our hypotenuse. This is what we're looking for, so we leave that as a variable. 4 plus 25 equals c squared. 29 equals c squared. Anytime you are solving for a square root or for a squared number, you have to do the opposite of that, which is to take a square root. Okay, I know that I did that pretty fast, but all you're doing is you draw your triangle, you plug it in to Pythagorean theorem. 2 squared plus 5 squared equals c squared. So it goes up 5 over 2. You square those two numbers, add them together, and then you get square root of 29. So c is going to be square root of 29. You get the same answer. There's two different ways. You just need to choose which one. It's either distance formula or it can be Pythagorean theorem. All right, here is the important part of what we are doing. All of that should have been review. This is what is new today. We are going to write some evidence down. So make sure you write that word down. So evidence, that is what is important. And what we're going to do is look at the slopes and distance and write down what it tells us. So we can look, LM and NO have the same slope, and we know that that means something. Anytime it has the same slope, the lines are going to be parallel. So it's going to look like this. LM is parallel to NO because they have the same slope. LM is parallel to NO. MN and OL have the same slope. So MN is parallel to OL. Right, and then since these are segments, I'm going to put that segment on top. You don't really have to. It's not super important that you have that segment notated. All right, that's all we can tell about the slopes. We know that they're the same, so that's our evidence. From this, you get those two. Right? And then from our distances, we're going to figure out two things. LM and NO have the same distance. That means they are congruent. Right? So MN I accidentally wrote it backwards. MN and OL are going to be congruent. So here's the deal. you don't have to write these. All you have to write is this, NM is equal to OL. If you write the congruent symbol, that's when you have to add that. So if you just write this down here, that's the exact same thing. It's perfectly fine. So distance gives us that for the evidence. All right, we're going to do more of these. So don't freak out if you don't understand. We're going to flip to the next page. On the next page, we don't have to do as much work. It's a little less, because it's already graphed for us, and the slope and the distance is already given to us. So we just have to figure out what this tells us. All right, we know for the slopes, we've got 2 parallel sides, and we've got, yeah, these two are parallel, those two are parallel. But if we look over here, we also, it looks like we have right angles. So if it's telling us that we need to say it's a rectangle, then we need to notice that these two slopes are something else. They are opposite reciprocals. All right, 1/2 and -2, it's where you flip it and change the sign. So instead of writing -2 over 1, which is the same as -2, you flip it to a positive 1/2. They're opposite reciprocals. That means that they are perpendicular. So hopefully you remember that. If you don't, that's okay. So we've got GH is perpendicular to HI. Okay, notice what we just did there. GH and HI, they're perpendicular. There's a right angle. So we're going to need 4 of these to show that there's 4 right angles here. HI is perpendicular to IJ, another right angle. IJ is perpendicular to JG, another right angle. And then JG is perpendicular to GH. There we go. Another right angle. So we've shown that we have 4 right angles there. We can also show that we have 2 are parallel. So these opposite sides, anytime they're the same, they're going to be parallel. So GH and IJ parallel. And we've got HI and JG are parallel. So you're looking for 2 things for slope. They're either going to be parallel or perpendicular. And this one, they're both. So these 2 are parallel, and then we've got 4 perpendicular lines where we have 4 right angles. All right, and then for the distance, finally, we're looking over here. We've got those 2 are the same, and these 2 are the same. So we have to write that. GH is going to be equal to IJ, because they're both 2√5. And then HI is going to be equal to JG. So notice what we have going on. Anytime it's coming from the slope column, you're either going to put perpendicular or parallel. Anytime it's coming from the distance column, you're going to put an equal symbol. So distance, you're going to put an equal symbol on the evidence. Slope, it's parallel or perpendicular. Hopefully that'll make a little more sense to you after you write those down and figure that out. All right, moving on. We're going to graph this. It's A is -2, 3. B is 2, 6. C is 7, 6. D is 3, 3. 3, 3. Okay. A, B, C, D. There we go. All right. Now, we need to find the distances and the slopes. I don't want to scoot that out too much. Distances and the slopes of the side. I'm going to say slope. I'm going to say distance. I'll write all these down. Write them down with me. AB, BC, CD, DA. AB, BC, CD, DA. You write all those down. It says to prove that it is a rhombus. So some things we learned about a rhombus last time. We learned that the adjacent sides are equal and also prove all four sides are equal. If you do this, method 3, you don't have to do method 2, so we're going to cross that out. We're going to prove that all four sides are equal, and we're going to prove that the diagonals are perpendicular. Alright, so I'll talk about what that means in just a second. Our distances, let's go ahead and do those first. For the distances, we just count 1, 2, 3, 4, 5 over for AD. And then for BC, we count the same and it ends up being the same. I'm going to do Pythagorean theorem again for this. So I'll show you. So I started at A, dotted line up to B, and then over to B. So it goes up 3 over 4. So 3 squared plus 4 squared equals C squared. 3 times 3, that's 9. 4 times 4, that's 16. Those are those perfect squares, 9 and 16 that y'all are familiar with. You add those together, you get 25. And then we want to take the square root of both sides. And the square root of 25 is 5. So anytime you can take the square root and it becomes a whole number and it's pretty, we'll go ahead and take that whole number. We wouldn't want to put square root of 25 up here. And so that is going to be 5. CD will be 5. I'm kind of jumping the gun a little bit. I'll show you. This is also 3 and 4. So if it has the same sides for that triangle, then it's automatically going to be 5 for the third side. Alright, wonderful. Done with distance. Let's look at slope. So we've got two sides with a 0 slope, BC and AD. Alright. Slope from A to B, it goes up 3 over 4. CD, up 3 over 4. Alright. And then the evidence. So we want to prove that the diagonals are perpendicular and prove that all four sides are equal. Alright, because we're trying to prove this is a rhombus. So what's important about it being a rhombus is that these two things are true. So we care about this distance. We know that AB is going to be our evidence. I'll write that. It's important that you write evidence. So when you look back in the notes, you know what's going on. AB is equal to BC, which is equal to CD, which is equal to DA. Boom. Done. Method 3. We've proved that all four sides are equal. Prove that the diagonals are perpendicular. First of all, what is a diagonal? It is going across the shape. So you're connecting the opposite sides, A and C, B and D. So for this one, diagonals, we need to figure out what the slope is, because it says perpendicular. And if they're perpendicular, they have opposite reciprocal slopes. So BD goes down 3 and over 1. So if we put Bob on this line, and we put somebody on this line, he's walking to the right, he's going down. So it has to be a negative. So it's negative 3 because it goes down 3 and over 1. For AC, it goes up 3 and over 9. I'll spare you the counting. So up 3 over 9, 3 over 9, simplifies to 1 over 3. Alright, what does this tell us? They are opposite reciprocals. So that means that AC is perpendicular to BD. Okay, so anytime you have a rhombus, this is a way to show that the diagonals are perpendicular. Okay, so notice what a rhombus does not have that a rectangle does have. Rectangle has 4 right angles because it has 4 perpendicular sides. A rhombus has 4 equal sides, no right angles. That's the difference. They both take the 2 things from a square, the right angles and all sides the same, and each one has 1. A rhombus has the sides the same, rectangle has the right angles, and the sides are not the same. Okay? Let's move on. This is actually going to be our last example. So let's look at this real quick. It says to prove that it is a square. So we want to prove that this is a square using the slope and the distance. So if it is a square, then we have to prove that there's 4 right angles and all the sides are the same. Alright, so our evidence would be that all the sides are the same. So AB is congruent to BC, which is congruent to CD, which is congruent to DA. All the sides are the same. So boom, we figured that out. All the sides are the same. Now we have to show that there's 4 right angles. Well, for this to be a right angle, AD and DC have to be perpendicular to one another. So AD has -4 over 3 slope. CD, look, the sign changes and it's just flipped. So it's positive 3 over 4. Alright? So that means CD is perpendicular to DA. That's 1. Okay? We've proven that. Now we got to prove this one. DC is perpendicular to CB. Cool. We've proved that one. Let's prove that right angle. This side, BC, is perpendicular to AB. And if we look here, BC and AB, one of them's 3 over 4, one of them's flipped with the sign change. So that's what makes it perpendicular. That one's proven. This last one, AB, is perpendicular to AD. Alright. Cool. So here, the next 4 problems are going to be your homework. So page 7, page 8, and page 9 is what you're going to do for your homework. And all you are doing is writing down the evidence. That is what your homework's going to be. So I'm going to start you off on this one. So here's how it's going to look. You're going to put the evidence down here. You're going to show me what you have. So look through your notes. There's a square, there's a rhombus, there's a rectangle, and there's a parallelogram. That's what each one of these are going to be. You've got 4 examples and 4 questions for the homework. There's going to be 1 of each. So you need to write the evidence down that this gives you. Feel free to look at the picture and think, oh, that might be something, maybe a rectangle, hint, hint, and go back to the rectangle and see what we wrote down for rectangle. You're going to do something similar. Okay, that's going to be your homework. This one on page 7, and then page 8 and page 9. Number 2 on page 8. Also number 2 on page 8. And this one's also number 2. So there's 4 2s that you got to do. Alright, thank you for listening to the video.